Good morning, class. Today we're going to be looking at how to manipulate variables. So first thing we're going to do is we're going to open up BlueJ, go to your Unit 1 package, and you're going to create a new class. So again, you select anywhere here to create a new class. Doesn't matter what you call it, class name, and we're like blah, 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 blah. There we go. There's our class name. Does not matter. Okay. Now, I emailed you this morning all the program you need. So go to the email that I sent you, copy everything that you got in the email, select and delete everything in this file that you just made, and paste the whole email. This is your notes that we're going to be looking at here today. All right, so scroll all the way to the top. We got a lot of ideas and concepts we're going to be looking at that are built into these notes that I just sent you. And the nice thing is you can watch this video as many times as you need to as long as many times it takes to understand the ideas that are in here. So the first thing to notice is here up at the top. This is a comment. The program ignores comments. The comments are there solely for us, the programmers' benefits. Now, we can create multiple different styles of comments. One is to do this /**, and the comment is ended by a //. So everything from here to here is commented out of the program. So again, the program ignores it. So the top of the program, we have a comment that describes what this class is going to do. And in this scenario, it's talking about variables. Okay, so let's move on. Remember, the first thing you need in every single program is the package of where it is, and then public class name, a brace, public static void main, and then another brace. We need these sorts of things on every single program you create. All right, moving on. So again, I have this comment here. Again, the program's going to ignore it. It's going through a series of notes. I use comments a lot for notes. Okay, so we're going to talk about variables today. Variables are a way for a computer to store data. And that data could be things like numbers, letters, even whole words. Now, the two major data types that we're going to be using are ints and doubles. Ints can only hold whole numbers, such as 1, 10, 1,300, -25, 0. We're going to be using ints a lot. Doubles we're also going to be using. Doubles can hold any real number. So it can hold decimal values. So it could hold 3.45, -7.89. There are many other data types, some of which we won't really use, some of which we will use later on. But I'm going to mention them now. A long is a larger version of an int, so it can hold larger numbers. A float's actually a smaller number of a double. Char can hold a single letter. Boolean, well, you can hold true or false. And a short is an even smaller version of int. Now you're probably wondering why I would want to use some of these, and it just depends upon the situation. Now, to create a variable, we need its data type, and we need to give the variable a name. And so the way it works is you say data type, space, name, and then we're going to do a semicolon. So an example, int x, semicolon. All right, so let's print out the fact that this is notes. So remember, to print, we're going to be using system.out.println, and then everything that we're putting inside those parentheses is going to be in quotes. So we're going to declare x, int x, semicolon. Now, these two slashes are also comments. Again, the computer ignores comments. Everything after on the same line of these two slashes is commented out. So everything after these two slashes like this here, system.out, is commented out. Now the reason this line is commented out is because right now it won't work if I uncomment. So watch, I'm going to uncomment this line. Notice how it changed color. I hit compile, and it's going to give me an error. Ignore that, what just happened, ignore that. It's going to give me an error. Error found in class. I click on this little error. Variable x might not have been initialized. Okay, so I'm going to re-comment that line out so it ignores it. What it was telling me was that x had not been initialized. I've declared x exists, but it has no value. Therefore, I can't use it yet. I have to give it a value. And so this line here initializes x. I give it an initial value of 10. Now I can print it. Now remember, when I'm printing things, I can print more than just stuff in quotes. So here I'm printing out x equals. I use the plus sign to separate everything out that I'm going to be doing on a print statement. That's going to concatenate this and this together. So here it's going to print out not the letter x. It's actually going to print the value of our variable x. So I'm going to hit compile. I'm going to go back to our main screen here. And I'm going to run it. I'm going to click on it and go to main. There's a lot of stuff printing out because there's a lot of things in this notes. Well, look, notes part 1. See how it prints x equals 10? Well, that's what I'm trying to print here. X equals, and then the value of x. So that's how we declare variables, and that's how we initialize variables. All right, let's move on. We can declare and initialize a variable in the same step. So here I can say int y equals 20. So now y exists. Y is an int, which means it can hold whole numbers only, and it has a value of 20. Now I can't redeclare a variable that already exists. So I can't say int x again. So watch, if I try doing that, it's going to give me an error. X is already defined. So I only can declare a variable once. I can declare multiple variables at the same time. So int a, int b, int c. Here, a and b were not initialized, but c was. It was given a value of 3. Here, d is given the value of 20, e is given the value of negative 3.4, and f is given the value of 9.78. Remember, doubles can hold any real number, which means they can hold decimal values. All right, moving on. Okay, so there's naming conventions for variables. We can't just name a variable anything that we want. We have to actually abide by a certain set of conventions for these. And this idea applies to things you name classes and methods and so forth. So the name of a variable must be relevant to what it does. So if I have a variable that is somehow representative of the temperature, a variable name like temp makes sense, but a variable name like Bob doesn't, or a variable like X doesn't. So your variable name should make sense. The first letter of the variable should be lowercase. But if you have multiple words, the first letter should be capitalized of those additional words. So look, interest rate. So notice how the R is capitalized. If I did it all as one word, all with lower cases, it becomes much harder to read. Another way to do it is to use an underscore between different words. So again, look at these two things. You can tell the first one is much harder to read versus the second one. It's kind of like how you use spaces to separate words. It's the same idea. We want to make the name easy to read. Now, there's some things we can't use to name variables. Can't be named reserved words. Reserved words are words such as if, for, new, while, and we're going to learn about some of those words later on. Can't start with a number. We can't use special symbols. In other words, I couldn't use like a question mark or an asterisk. And I can't use spaces. I can use an underscore, but I can't use spaces. All right, moving on. Now, if you need to, you can restart this video to rewatch those notes. It's a good place to stop and rewatch those. All right, part 2. Remember previously, x and y had been declared. Let's relook at those. Y is an int, x is an int. So they can't hold decimal values. So x equals 5, y equals negative 12. I print them out. Remember, we use that plus sign to separate things. So notes part 2, x equals 5, y equals negative 12. Now, we're going to assign to the value of x the current value of x plus 15. So what this line code is saying, I'm going to assign to x, that's what the x equals, so I'm assigning what's over here, whatever this end result is, I'm going to assign to x. So when this line of code is done, the x is going to hold whatever this value is. So what is x plus 15? Well, I have to use the current value of x, which is 5. So 5 plus 15 is 20. So x is now 20. And so when I print off x here, notice it prints x is 20 now. Okay, I keep going. Remember, x is 20. It's not 5 anymore. So here again, I'm assigning to x the value of x plus y. Well, x is 20. Y is negative 12. So 20 plus negative 12 is 8. So x is now 8. And so this is going to print x equals 8. All right. Next example. So I change x and y. X is now 5. Y is negative 12. So this line of code, so I'm assigned to x. I'm assigned to it the value of x plus 3 minus y. So minus negative 12. So that is 5 plus 3 plus 12. So 5 plus 3 is 8. 8 plus 12 is 20. So x equals 20. Now I get the next line of code. I'm assigning to the value y 4 minus y. So remember, y is a negative 12. So minus a negative 12 plus x. X is 20. So that's 4 plus 12 plus 20. And that equals 36. So I'm going to print off x and y. X is 20, y is 36. Now, look at these two lines of code. They both do the same thing. You set x equal to x minus y, and y equal to x minus y. So you might be thinking to yourself, oh, these are going to give the same value to x and y when I'm done. But we do this one line of code at a time. So I'm going to set x equal to x minus y, which equals negative 16. So x is now negative 16. Then I assign to y the value of x, which is negative 16, minus y, And you'll notice I'm not going to get the same thing. Negative 16 minus 36 is not going to give me negative 16. I'm going to get negative 52. So when I print off x and y, it's negative 16, negative 52. So this shows us that even though these two lines of code are doing this more or less the same thing, x minus y, I have to do one line of code at a time, because when I got to this line, x's value had changed. It no longer was 20, it was now negative 16. Thus, this line of code gave me a different value. All right. Now I'm going to do, what is 1/2? So 1 divided by 2 equals, and then I'm going to do this. No, I put it in parentheses to make sure there is no confusion about our order of operations. So I'm going to do 1 divided by 2 first, and then I'm going to concatenate that result onto the end of this. Now, let's see what we get. 1 divided by 2, you guys are all probably thinking, oh, 1 divided by 2, that's 0.5. But here you'll notice we got 0, not 0.5. Why is that? Well, when we do division with ints, our result is an int. An int divided by an int is an int. Remember, ints can't have decimal values. So what happens to that 0.5? Does it get rounded? No. The decimal values are truncated off. They're just cut off. The decimal values are thrown away. So I could have 0.9999999, and when I truncate that, that's going to leave me with just 0. We don't round. We just cut it off. We throw it away. So here, 10 divided by 3 is just simply 3. And the next one, 153 divided by 10, is 15. Again, the decimal values are thrown away. So if I do an int divided by an int, my result's an int. If I use a double in any of these, I get a double. So look, double divided by an int is a double. Int divided by a double is a double. Double divided by a double is a double. So look, here I print 1 divided by 2.0. That's an int divided by a double. So my result is a double, 0.5. Here I'm going to store the result into a double z, 1.0 divided by 2, and it's going to print us off 0.5. Now, notice here, x equals 1.0 divided by 2. I compile it, it gives me an error, because this is a double divided by an int, which is a double, and I cannot store a double into an int. So that gives me an error. Now, if I did this, z equals 1 divided by 2, remember, that's an int divided by an int, which will yield an int. This would, if I printed off z here, this would print 0. All right, we're in the last little bit of idea here for the notes. Math operators. Now, addition, subtraction, multiplication, division, they're all there. And PEMDAS applies, which means multiplication and division, they go at the same time, left to right, and they go before addition and subtraction. Addition and subtraction go at the same time, left to right. The caret, which you guys use on your calculator, do exponents, does not do exponents in Java. It does something else, so don't use it. But we do have a new operator I'm going to show you, which is the percent sign, which is modulo. Modulo gives us the remainder of division, and it's going to go at the same time as multiplication and division. Now, I'm going to show you how modulo works here.
So imagine you're doing 5 divided by 3. I'm going to do this in long division. So long division, how many times does 3 go into 5? It goes into it 1 time. 1 times 3 is 3. I subtract them. I'm left with 2. So the remainder is 2. This is what modulo gives us. 5 modulo 3 is 2. Modulo gives us the remainder. Let's do another one. Let's say we do, let's do 10 divided by 4. So again, I'm going to break this into long division. How many times does 4 go into 10? 4 goes into 10 2 times. 10 times 4 is 8. 10 minus 8 is 2. So our remainder is 2. And that's what 10 modulo 4 gives us. Modulo gives us the remainder. Back to our notes. And these are doing the same thing here. So 5 modulo 3, the remainder is 2. Whenever you do a small modulo large, the remainder is a small number. That's because the large can't go into the small. Think about it. 2 divided by 10. Can 10 go into 2? No. So you're left with the original number. And so look at this. 5 modulo 3, 3 modulo 5, 8 modulo 2. You can see those results. 5 modulo 3 is 2. 3 modulo 5 is 3. Because again, can 5 go into 3? 5 goes into 3 0 times, leaving us the remainder of 3. 8